let's start. We're going to talk about CICD. This is our agenda, the topics that we are going to cover. And the first question that we need to answer is what is a CI or CD? CI means continuous integration, which is pretty much when you create a pull request and you push some changes, it is going to run a few tasks. And these tasks are the continuous integration. So a good example was the Docker images. Every time we create a pull request and you run a push, it is going to build all of our Docker images. So this is going to be continuous. It will happen every time that we do a push and a pull request. So let me just show to you guys a simple example of our pipeline here on Azure DevOps. So every time that a pull request is created, it's going to run this build. And one simple task that this is going to do is to run unit tests. So every time we do some change, if we break a unit test, the build is going to tell us what's happening because it is separated in a lot of tasks. And continuous deployment is pretty much related to integration. But the difference is that it is not going to run a build-like integration. It's going to deploy through our cloud every time a pull request is closed. So this is good because we don't need to rely on someone to do pushes every time we do something. We don't have an example like we have in integration because our CD is not implemented yet. But that's pretty much it. Every time a source code is deployed to a repository, it's going to be pushed to Azure DevOps, for example. So what makes a good CI? It's the different stages that we have here. So we have one task to use .NET Core. We have another task to run unit tests. All these are stages. They are separate tasks that are going to run every time the build is deployed. And it's repeatable, so it is automated in a way that we don't need to do it manually. We also don't need a human to do these tasks. Like I said to you guys, every time a pull request is created, it is going to run, so we don't have to worry about it. And it's fail fast. What does it mean? So every time something fails, like this pull request, here it's happening an error on Docker image. If we click on this task, we can see more details about what happened. So we know that something happened when trying to clean the images. I don't know, to be honest. But yeah, we can see what is going on. We can see why it's breaking. And if we choose to, every time the build breaks, we can't approve the pull request, so we can't do the deployment. So this is a dashboard, and these are some errors. And what makes a good CD, a continuous deployment? This is what makes the different versions. So this is something that we have at the moment. So every time we do a deployment in the future, we are going to know which deployment it was, to which pull request it was related, and who did it. And also, like I said previously about the CI, the deployment should not be dependent from the developer. So it's going to be automatically. So we don't waste time doing some things, getting access to FTP like the old way. And this is just a cool image that I like to show to you guys, which means the more complex and more complete we have our tasks, more it's going to cost and more time it's going to take. So in the beginning, we have only unit tests. It was very fast, like this rabbit here. And the cost is why it was almost zero. But now that we are going to have more things, it's going to be a little slow. So if we see the time here in this build that was completed, it takes some time. So yeah, more things we do, the more time it's going to take. And you guys may ask, why do you need CI/CD? Why do you need to change? and use these new things. And it's very simple. We need to reduction the delivery risk, so we don't deliver something that has a build that is broken. And like I said to you guys, we don't need to rely on humans with specific knowledge. Because imagine if we had to do everything manually. You will need to have Linux knowledge, you will need to have Docker knowledge, and a lot of stuff that is present in the tasks that we are running here. So with this, it's become way easier to anyone do it. And it's reduced the chance of humans not following the entire process. So this means that we are not going to have a pull request that is with a broken build or a deployment with a broken build. And also reduce the chance of mixed communication. It's pretty much like the point that I said here. And the last point is that we are delivering things with reduced effort. So if we're going to see this build here, we are pretty much doing nothing. We just did a push, and the agent from Azure DevOps did everything to us. So yeah, this is pretty easy to us.